So let me continue with the Green's theorem. So in the last two recording, we have seen the important problems under Green's theorem. Now in this recording, we will see how we can find the area enclosed by any plane using Green's theorem. So it is a very important topic. So let me continue now. So employ means you need to apply Green's theorem in a plane to show that the area enclosed by curve C is half into integral C x dy minus y dx, and hence find the area of the ellipse x square by a square plus y square by b square equal to 1. So this is also considered as a formula. How to get it, we will see here. So Green's theorem in a plane to show that area enclosed by a curve. So whenever you will get area enclosed by a plane curve, such problems, what will be the area? Using Green's theorem, half into integral C x dy minus y dy. Remember this as a formula because we are using in the problems directly. Now how will you get it? We will see in this problem. See, we have from Green's theorem, integral C m dx plus n dy is equal to double integral over the region R dou n by dou x minus dou m by dou y dy dx. Correct? Usually I'll write dy dx. Write down in the same manner dy dx. Now, area enclosed by the curve. Whenever we'll say area, what do you mean by area? Area means double integral dx dy. You have studied in your lower classes. What do you mean by area? Double integral over the region R dx dy. Correct? Now let me take here. Let us take n equal to x by 2, m as minus 1. So this is the assumption we have made. So let me take n as what? X by 2 and m as minus 1. So you need to remember this. Let me take n as x by 2, m as minus y by 2. So when we take like this, can we notice here what will be dou n by 2? Is it half? But what will be dou m by dou? Is it minus half? Correct? No. So what will be the difference? Difference will be half minus or minus half equal to 1. So difference becomes 1. That is the reason why we have taken n as x by 2, m as minus y by 2. When we take n and m, when we choose n and m in this form, then the difference will be, partial difference will be 1. Now we can apply Green's theorem. See, what is the Green's theorem says? Integral C. What is m? We have taken minus y by 2, right? M as minus y. What is our n? N is x by 2 dy plus. What about double integral over the region? What is the difference we got? Difference is 1, right? Dx dy. Now what is this? According to our lower class, double integral over the region dx dy is nothing but area enclosed by the curves. So what we got? Area enclosed by the curves. See, what is the formula for area enclosed by the curves? See, half you can take out. So x dy minus y dx. So this is how we derived area enclosed by the curve. See, using which theorem? Green's theorem. Correct? Using Green's theorem, always area enclosed by the curve C is given by half into integral C x dy minus y dx. So using Green's theorem, we got area enclosed by the any curve will be, what will be the answer? Half into integral C x dy minus y dx. Only the thing is, you need to take the assumption n as x by 2, m as minus y by 2. Then automatically area comes. Okay. Next we'll see. We'll continue the problem. Now to find the area of the ellipse. You know, ellipse looks like this, right? So what is the boundary point of this? Minus a comma 0, a comma 0. Here 0 comma minus b, 0 comma b. Now can you write down the parametric equations? Do you remember the parametric equation for ellipse? See, when I put x equal to a cos theta, y as b cos theta, whether it satisfies, can we check here? See, when you put here x equal to a cos theta, a square, do you get cos square theta? When you put y as b sin theta, b square, do you get sin square? So what is cos square theta plus sin square theta? Is it 1? So these are the parametric equations of ellipse. So we can easily note down that these are the parametric equation of ellipse. If you want, you can check it. Just put it here, x and y. You will get the answer as 1. So these are the parametric equations of ellipse. Do you remember parametric equation of circle? In the last recording we have seen, right? X equal to a cos of y equal to a sin theta. Correct? Now here it is b, because we need to satisfy the equation. Then only we can see it is a parametric equation. Now what about theta? Theta varies from here to here, right? 0 to 2 pi. Now since we are asked to find the area of the ellipse, directly we'll write the formula using Green's theorem. Area is given by what? half into, I told you to remember, right? Using Green's theorem, we got this formula. Area is given by half into integral C x dy minus y dx. X you substitute. What is dy? Dy is nothing but b into cos theta d theta, right? Y you substitute. And what is dx? Differentiate this. A into what is the data cos theta minus sin theta d theta. So simplify, you will get AB cos square theta plus sin. So AB can be taken out. What is cos square theta plus sin square theta? 1. So theta. What is the integral of d theta? Theta. Put the limit, upper limit, lower limit. 2 cancel pi AB. This obviously you know, right? What is the area of the ellipse in general? Pi AB. The same thing we got using Green's theorem. So what is the area of the ellipse? Pi into AB square inverse. Now second question. Find the area of the asteroid x equal to a cos cube theta, y equal to a sin cube theta by employing Green's theorem. Here they have given the parametric equation. Sometimes they won't give, instead of giving like this, they will give x to the power 3 by 2 plus y to the power 3 by 2 is equal to a to the power 3, not 3 by 2, x to the power 2 by 3, y to the power 2 by 3 is equal to a to the power a to the power 3 by 2, I guess. Okay, so like that if they give, that is also equation of the asteroid. So that time you need to remember this parametric equation x equal to a cos cube theta, y equal to a sin cube theta. When you put it there, you will get the answer as the right hand side. Okay, so this is, we need to find the area now. So this is the shape of the asteroid. It is a star shaped curve. And what are the coordinates? This is 0, a, 0, minus, this is a, 0, minus a, 0. So what is the area formula? You know, area is half x dy minus y. Remember this. So line integral. Now can you see here? Area is, we are calculating the 4 times area in the first quadrant. Okay. So area 4 times area in the first quadrant. So this is the region here 1, 2, 3, 4. So instead of doing all the region, we will see only the area in the first quadrant. So in the first quadrant, can you make out? So in the first quadrant, I'll take only the first quadrant. Okay, I1 and I2 have taken. Actually, I need to write here area. This area is calculated only in the first quadrant. I am calculating. Okay. So this is half into, this is I1, this is I2. So along I1, what you are having x dy minus y dx. So this is, yeah, x into dy minus y dx. This, I think it has come from this different this thing. Okay, let me continue this problem later on. Let me go to the next problem. Okay. Evaluate integral c xy minus x square dx plus x square y dy, where c is a closed curve formed by the line y equal to 0, x equal to 1 and y equal to is directly as line integral and by Green's theorem. So asteroid, I'll do it later because one page is missing here. I'll write it and again I'll do the recording. Okay. Now evaluate, we'll see this problem, a very important problem. Evaluate integral c xy minus x square dx plus x square y dy, where c is a closed curve formed by this line y equal to 0, x equal to 1 and y equal to x, directly is line integral and by Green's theorem. So m is what? Xy minus n. What is n? X square y. So calculate dou m by dou y, dou n by dou s. Let me check the closed curves now. So what are the curves? They have given y equal to 0. Y equal to 0 means this line, correct? And x equal to 1. What do you mean by x equal to 1? X equal to 1. This line is called as x equal to 1, correct? And which line is called as y equal to x? This line is called as y equal to x, correct? The line is called as y equal to x. Now this is our region. This is our region of integration. And what is our path? O to A to B, B to O. So this is our path. So we need to evaluate 3 line integrals. OA, AB, BO. So split that line OA, AB, BO. So I1, I2, I3. So along OA, along this line, what is the equation of this line? We know y equal to 0, right? So what will be dy 0? So along OA, let me put wherever there is y 0 and dy is also 0. So you'll get minus x square d. So I need to put the limit for x. So which are the limit for x? X coordinate. X coordinate is for this line. X coordinate is 0 and x coordinate is 1. So 0 to 1. Integral of x square is x cubed by 3 minus 1 by 3. Now along AB, let me check now along AB. Now what is the equation of this line? This line is x equal to 1, right? So x equal to 1 means dx means what? 0, right? Now substitute here wherever there is put x as 1, x as 1, correct? X as 1 and dx as 0, dx as 0, you will get like this. And we need to put the limit for y. Can you tell me the y limit? Y limit. So y limit for this line, y limit is from 0 to 1. Y limit is from 0 to 1. So half you take out, apply the upper limit 1 by 2. Now along BO. Along BO means this line, along BO. So what is this line? Y equal to x. Correct? Y equal to. So what will be dy? Dy will be dx. So this is the third integral. Now wherever there is y, x. So whenever line integral is there, we need to convert in terms of one variable. Okay, so x is what is y? X dx. Dy is dx. Now I need to give the limit for x. So can you tell me the x limit? X limit is 1, here 1, and here it is 0. It starts from B, ends with 0. 1 to 0, correct? So actually it is 1 to 0. So I put minus 0 to 1. Okay, reverse direction. Minus 0. You can put 1 to 0. Okay, I put here minus 0 to 1. It is same as 1 to 0. Then integrate, you will get integration to the power 4 by 4. It is minus 1 by 4. Now add all the three things, you will get minus 1 by 12. So this is from where? This is from line integral. I did it using line integral. That is from the last topic. Correct? Na? Directly using line integral. Now let me do it by Green's theorem. Now from Green's theorem, how we can do it? I told you whenever they will give Green's theorem, you better to take the right hand side. What is the right hand side? Double integral over the region are dou n by dou x minus dou m by dou y dy dx. Okay, dy dx. Write down like this, dy dx. Now what is the difference in the partial derivative we have seen? Dou m by dou is x, dou n by dou x is so 2xy minus x. That gives you dy dx. Now I should give the limit for y and limit for x. So set the boundary. So how to set the boundary? See, this is our region. This region is covered by which lines? X equal to 0 and x equal to 1. So the boundary will be from 0 to 1. X boundary will be from 0 to 1. So since it is a vertical strip, you need to go from lower region to upper region. What is the lower region? What is the equation of this line? Y equal to 0. Here to here. So what is the equation of this line? Y equal to x. So y limit will be from 0 to x. So simplify, x can be taken on or just integrate with respect to y. 2x, what is integral of y? Y square by 2 minus x is constant. What is integral of dy? Y. So put the upper limit for y. So when you put x into x is x cube minus x is into x is square. Lower limit anyhow 0. Then integrate with respect to x to the power 4 by 4 minus x cube by 3 0 to 1 minus 1 by 12. So this is very important problem. This problem has been done directly using line integral as well as by Green's theorem. So we have evaluated. They have not asked verify, right? Evaluate. So we have used right hand side of the Green's theorem. And here we have used line integral. But both are same, right? Integral m dx plus n dy. What we got the same answer? Minus 1 by 2. So we can conclude that Green's theorem is also verified, correct? Na? So this is a very easy topic. So please practice the problems. Thank you.